Anyway, what you got here is, these are the 240 watt Kaiser panels that we've installed. The Solar Heart hot water heater used to sit right here, and we moved it over. That took me a lot of work and cost me some money. This is for a friend of mine, so I'm not really charging him that much, and he is on a budget, but just moving this damn thing probably absorbed most of my install cost right there. Existing, he has a Sanyo grid tie system, and this is one of those situations where he was sold this system by who's got a really big advertising budget right now, and told either naively or falsely that when there is a blackout that this system would work. Now, as you can see, the existing conditions are that this client has a grid tie system. See that box on the inside? It runs over to the main meter. So this is a grid tie system. And the reason you don't have a big box down here, that's just a cutoff box really, is that these panels have microinverters on the bottom of them. So what we're doing is we're going to add a system with a standard inverter alongside these, so that he can have both grid tie and standalone solar power. It's funny, as you can see, many of Larry's neighbors have solar installations as well. These are all grid tie systems. But the problem is that when the power goes out, his neighbors will not have power coming off of their solar. They won't have any power if they have grid tie systems. Now what you can see is what we've done is we've taken our 240 watt panels and spliced them. We got these inline splices right there, and then we've taken some heat shrink and covered those guys. And so each panel is, we've done that too, and then connected it with some number 8 landscape wire. And so we'll be bringing those each into a box. There's a row, there's a row. And then over here, don't get sick from looking at this, we kind of ran out of the wire, so I just put the conduit. We could run everything in the box. So over here we won't even need the heat shrink. We're just going to wire it directly. And so of course in these boxes I could use single wires as opposed to like a Romex or something like that, which will save me some money in the end. And it took me a little bit of cost for putting the boxes in, but it's actually like working with Legos. Now all this is going down to, that's going to have a 90-degree bend going down through the roof, which will then come down into here, and then through the roof of this shed here. And inside the shed we have it set up for putting batteries and a spot for the ready to go. Okay, so this is where the ready to go will find its permanent home. You can see the shed was built for storage, but it's actually a perfect situation. The owner built a couple shelves here to allow for batteries, and what we've done is we've drilled a hole through the roof, which we will caulk around. But as you can see, it's got a roof over the roof. So in this case, we've got some things working for us here. Anyway, so as you can see, extra batteries will go there. ready to go, will sit right there. We'll just roll it right in, plug it into the system, plug and play. Coming out of the shed, you see I have a 1.5 inch pipe that goes up through the wall into the attic. Now this is where we've penetrated the roof and gone through the wall, and the purpose of this pipe is to bring power. So this is supplemental, or you could say creating your own power from this source. It's very similar to what you'd have to do if you were bringing in grid power. Now up here you can see where that pipe comes from the wall, and we've got it running down. We're going to connect that to a hole we're drilling in the walls here. We'll show you downstairs in just a second. But that pipe, technically, now this is where you really need to talk to your electrician and or engineer about your specific code requirements. Where we're doing this does not require that pipe. Just like you can see this Romex down here isn't required to be in a metal or plastic housing. That's why it's Romex. But the reason for that is because it's in an area that usually is not accessible to people. So this is what's running through your walls. It's what's running in your attic. And usually you don't pull this, put a pipe like this, unless you're doing something like what we're doing. What we're doing is we're setting it up so that eventually we could have more circuits, more power coming through that pipe. And so we know we're going to be pulling wires back and forth over the years as we increase our system. So this pipe is a really good idea, because it's like 150 degrees up here, and that's why you don't want to be coming up here to be pulling wires as little as you can. And now you have the pipe, you can see, going all the way down into the wall, so we can pull power into that portion of the wall. That 1.5 inch pipe that runs through the attic comes down to this hole, which will continue on down to a box, which we're going to put in the wall right here. There is already an existing main circuit breaker box. We are going to be putting in a sub panel that'll be run off the solar and will connect with the main via a automatic transfer switch. So there's the hole that we drilled in the ceiling, which will come down. We'll be putting a box in this wall right here, very similar to the main circuit breaker box. And if you look over here just down the hall, we've opened it up so you can see this is the main circuit breaker box right here. And you can see all the wires coming up. And this guy right here, that's your main power coming in. So we're going to do the same thing. We're going to have our main power coming in just a few feet over for our new box. We're going to split off a few circuits, and then we'll have alternative power. Now to cut out the box, you can see we already cut something out there at the top to drill our hole to go into the attic. This is a simple remodel. What I recommend is using, you could use razor knife or skill saw, which is not as recommended. Sawzall can get quite messy, but these little guys, these multi-tools, perfect for this job. And I need to thank one of my clients and all-around good people, Cowie Wilcox, for convincing me to finally get one of these. Okay. Now I'm cutting just so deep to make sure that I don't hit any wires behind there. Code requires that the wire should be at least an inch back from the drywall, and you can see there are wires in here. So it's better to assume that there are wires. So only bring your tool in as far as you need to. Okay, I've got all my cutting done. Just got to pull the drywall out now. Or, Man of Steel. And there you have the box installed with a main, which will be wired through that hole. Still just showing you that it's in, but we will be pulling the wires now next.